Okay, I've got a question here. I want to rationalise this expression. And this is another video regarding surds. So notice here, we've got 4 root 5 divided by 7 minus 3 root 3. Now to rationalise it, what we want to do is to get rid of this surd in our denominator, because that's not good for us. Now the reason we do that is if we have a surd in our denominator, this is what can happen. Now if I compare two fractions, square root of 2 over 3 and 3 over square root of 2. Now, first of all, let's have a look at this one. If I put that into a short division, I will have 3 into square root of 2. Now, if I plug that into a calculator, I will get 1.41421 and going on forever. Now, to start off with this, we can do this as short division. 3's into 1 is 0, carry 1. Put a decimal point. 3's into 14 go 4, carry 2. 3's into 21 go 7, carry none. 3's into 4 go 1, carry 1. 3's into 12 go 4. And 3's into 1 go 0. And then we have to create another one here, and so on and so on. So this we can do it. What about the other way round? Well, if I want to write this in short division, I'll have my 3. Let's just bring it forward a bit. I would have my 3 inside the box. Then outside of the box, I would have this. Now this now looks a lot more awkward. And as this is a forever recurring decimal, that goes on forever, this is not going to work. So hence that's why we want to rationalise our denominators. Okay, let's take this off the board. Right, let's have a look at this question. So now 4 root 5 over 7 minus 3 root 3. Now the technique we use to get this surd out of the bottom is we want to have some sort of difference of squares result in our denominator to help us get rid of this square root. So what we do is we create a 1. So if I multiply this by 1, nothing's going to change. So I now make an expression that is just the same as 1. So using this, what I want to do is just to flip the sign and keep the surd. So now I've got 7 plus 3 root 3. And then as I'm trying to multiply by 1, if I just make my numerator the same as my denominator, it will equal to 1. So that's what we've got there. So that's the same term. So now what I do is I just multiply. And then good things are going to happen. So 4 root 5, let's write that up here. 4 root 5, I multiply that by 7 plus 3 root 3. And then my denominator, I've got these two terms here. 7 minus 3 root 3 times 7 plus 3 root 3. Okay, now that looks like quite a lot, but what we have to do is just go through it methodically and simplify it. So this is out of the bracket, so we multiply that with every term in the bracket. So I'll multiply with that one and that one. So let's bring this down onto the next line. So I've got 7 times 4 root 5. Well, 7 4s are 28, and then the root 5 will stay. So I've now got 28 times root 5. Now 4 root 5, I now have to multiply with this 3 root 3. Now we've just got to be careful here. So we do the integers first. So notice there's a plus sign here. So we're multiplying everything with that plus sign. So it's plus 12, and then we need to still carry on multiplying the root 5 times the root 3, so we do the surd separately. So we can multiply just the numbers inside the surd together to give us another surd. So 5 3s are 15, so that gives us 12 root 15. Okay, now our denominator, that's going to give us an interesting result. Distribute this 7 with everything on these terms on the other side. 7 times 7 is 49, and then 7 times 3 root 3, 7 3s are 21, and then the root 3 will stay. So that will be a plus sign. By virtue we have a plus sign there. So that's plus 21 root 3. Now we need to distribute this minus 3 root 3, so don't forget that sign with these two terms here on the other side. So minus 3 root 3 times 7. 7 3s are 21, but not forgetting the minus. So we want minus 21 root 3. Need a bit of space here. And then here we've got minus 3 root 3 times plus 3 root 3. So then that's going to give us minus 3 times plus 3 is minus 9. Root 3 times root 3 is just 3. So that's just going to give us 27. So that's the same as 27. So I can just change that. Let's put minus 27. Okay, let's just simplify this up on the next line. So 28 root 5 plus 12 root 15. Let's just leave that as it is. And then on my denominator, something good is now going to happen. 49 minus 27, that's my integer taken care of. So that's 22. Now here, plus 21 root 3 minus 21 root 3, they will just disappear. Hence now I've got no surd in my denominator, and that's the desired rule that we wanted. Now we can simplify this even more. 28, 12 and 22, they all divide by 2. So that one will become 11, that one will become 14, that one will become 6. So we can now put in our final answer as 14 root 5 plus 6 root 15 divided by 11. So that is our answer rationalised. This result here, that's the same as that being rationalised. Okay.